So in physics at the moment we're looking at Newton's laws of motion, and there's three. We've got inertia, so an object will remain at rest or in its current state of motion unless it's acted upon by an unbalanced force. We've got force equals mass times acceleration, and for every action there's an equal but opposite reaction. So Reuben and I thought we might explore that with you guys today, and we're down at Primrose and we've got our kite buggy, which is this awesome contraption over here, and we'll get you guys thinking a little bit. How do you think it is that first of all the wind can power this thing just using a little kite, and things like how do we get that buggy going even faster than the wind speed, and I mean really fast. This thing really moves along when it gets going. And how, looking at Newton's third law, because this was the thing that always boggled me at school, if there's, for every action there's an equal but opposite reaction, how do we actually even move forward? We'll have a bit of a play, and Reuben might jump on the camera for me and do some videoing. So to make sense of all of this, Newton's laws of motion that we went through earlier, we've got inertia, we've got force equals mass times acceleration, and we've got for every action there's an equal but opposite reaction. That law number 3 is a really great one to look at with the kite buggy, because that's really what's happening here. If you have a look at me standing on the beach holding onto the kite's pulling me with force, I'm pulling back on the kite, and nothing's happening. And this is the result of a lot of forces going on here. So ultimately the friction underneath my feet is what's preventing me from moving forward with the kite. But if we put me in the buggy, suddenly there's no friction underneath my feet. It's been massively reduced because I've got wheels that have got bearings that run smoothly in it. And so now, instead of the forces being balanced, the force pulling me is greater than the force that I'm exerting back on the kite, and so I start to roll forward because of the balance of forces. And if we have another think about law number 1, the law of inertia, this is a body's tendency to resist change to either its direction or to its speed. And there was a good example of that during the video here where I go around a corner a bit too enthusiastically and poor Reuben nearly tips out the side of the buggy. And he does that because of his body's resistance to change. He's happily travelling along at a set speed and direction, and suddenly I change that. And so his body tries to leave the side of the kite buggy in order to continue in its same speed and direction. And the last question I posed to you is, how is it that this kite buggy can actually exceed the speed of the wind? And that's by generating something called relative wind. And this is a combination of forces on the kite. So to better try and understand that, I might have a look at this top view of the kite buggy. And we're experiencing true wind, which is the real wind, the wind that's coming in from the water, from the side. And today that was about 20 kilometers an hour. But the buggy's traveling forward at least 40 kilometers an hour. And if you're walking forwards, you can feel the wind blowing against your face. So if we're traveling forwards at 40 kilometers an hour, we're also experiencing the force of that wind coming at our faces at 40 kilometers per hour. But because of the opposing force, the true wind that was coming in from the side, a combination of that true wind plus the wind that we're receiving in our faces creates something called relative wind, which is this force here. And that presses against us with more force than either of those two opposing forces. And that's how we continue to fly even faster, because as the buggy speeds up and we push the kite harder into the wind and fly faster, we experience more force on the kite. And in turn, that drives us faster.